Look at that, right on time. We're going to just roll right into our next speaker before we start our Q&A segment. So I'd like to introduce Dr. Julie Robinson.
Hi, everyone. Thanks so much for inviting me to talk to you a little bit about probably one of the most boring things that we do at NASA in terms of organizing the way that we're working together, but also as I see from a lot of the questions and answers coming out, you recognize it's also one of the most important things that we need to do, because to do successful science and technology utilization across 3 mission directorates, across very complicated missions, and across multiple different selections of both robotic and human missions, we really need to have our coordination act together. So I'm happy to give you some updates about what we've done over the past year. If we could go to the next chart. The first thing we had to do in HEO, and HEO's a big monster of a mission directorate, is we needed to get ourselves in order to be successful with Artemis. So over the past year, in the middle of a pandemic, we also did a significant reorg. And I'll only mention a couple of highlights from that. The first is that we organized our programs and projects into divisions with a more consistent set of governance. And that includes down here in blue, our Exploration Systems Development Division focused on launching ground systems and Orion, and then our Advanced Exploration Systems Division focused on Gateway and the Human Landing Program, and especially on the near-term mission operations. But we also have a lot of activities going on in our Commercial Spaceflight Development Division, helping us to use innovative procurements, and the International Space Station Division continuing their work in low Earth orbit, and then finally Human Spaceflight Capabilities Division, which is now the home of the Human Research Program. At the same time, just those 5 divisions still need to be coordinated together, because each of those divisions has a component of the overall enterprise and things that need to be done by those divisions in order to make Artemis successful. And so to do that, we have established a new organization at the mission directorate level, and that is the box in black you see at the upper right. So Marshall Smith is our deputy AA for HEO Systems Engineering and Integration, because good top-level requirements that ensure all of those programs are working together in an integrated architecture is really important. And I'll talk, if we go to the next chart, I'd like to talk a little bit more about the way we structured that organization. So that's really serving as Kathy Leader's technical integration arm at the directorate level. And in addition to what Marshall is doing with Greg as his deputy, ensuring the overall strategy is reflected in our top level program requirements, we have the strategy and architecture team. They're working on all the aspects of Artemis and future Mars missions that are not yet formulated or translated into programs, including things like the Artemis Base Camp. Capability integration is really interfacing between technologies and the architecture to make sure that we're developing all the capabilities we'll need for those long-term missions. And then science and technology utilization, which I'll be talking about for the rest of my time, we're focused on integrating the science goals from SMD and the technology goals from STMD with HEO's goals into an integrated set of objectives for utilization. And that includes low Earth orbit, ISS, especially Artemis. That's a big part of our efforts, and also future Mars missions. Next chart. So a little bit of detail about this group. You'll recognize the names. I've been asked to be the acting manager of the organization, and Jake Bleacher, who you all know well, is continuing as our chief exploration scientist. We also have a chief technology integrator. Until just a few weeks ago, that was Jay Falker, on rotation from STMD, and we'll be selecting a new person for that role. We also have Betty Siegel and Mike Wade in our team office, and their names aren't all listed here, but we have a multi-center support team across Langley, Goddard, and JSC to give us the expertise we need to work with our colleagues in SMD, people like Sarah Noble and Brad Bailey, and make sure that we are integrating science and space technology and HEO together from a utilization perspective. We also carry for HEO the responsibility for working with SMD on the survey activities. So we work with Sarah Noble and Christina Gibbs and everyone there. And then we also have responsibility with Office of Planetary Protection, SMD and STMD colleagues for supporting the Planetary Protection Office. Next chart. So what we do, we don't make up the utilization requirements, but we do integrate them. So we make sure we understand the objectives of all the national mission directorates and international partners as they come into any human spaceflight platform, especially Artemis is a big focus right now. We document those as HEO requirements and make sure they get accepted by the divisions and programs so that we know that we've connected together both what the users need, what's being built and what's being planned, and then how that is accepted and taken as a requirement by the program. And we try to keep a strategic view. We're working at a directorate level, facilitate the communication between different orgs, and then advocate and explain the utilization within HEO. Next chart. So you've heard a couple times already this new acronym, the USIG, the Utilization, Coordination, and Integration Group. And this is what we have created in consultation with the Federated Board to make sure that we keep the 3 mission directorates coordinated from a utilization perspective. This is the first time this has ever happened at this intra-mission directorate level quite in this way for human spaceflight. So we have 3 mission directorate co-chairs, myself, Brad Bailey, as I mentioned, and Jonathan Bowie is representing STMD. We coordinate on a weekly basis with our Federated Board leaders. And our primary assignment is to work to integrate together the needs and requirements that will be the utilization objectives for the human missions in Artemis and documenting those in what we call HEO 006 or utilization plan. So we're very much living in a systems engineering focused organization. It's all about writing good requirements and documenting them. The boxes below just kind of give you a sense of the representation. We have multiple SMD organizations, which then are umbrellas for additional divisions and so forth. We work a lot with SEO, with Sarah Noble, with the BPS division and Kevin Sato. We work with heliophysics and astrophysics and earth science as appropriate, with STMD, with Human Research Program, which is still in HEO, and with AES enabling capabilities in HEO, as well as the Office of Planetary Protection, all of whom are stakeholders in the utilization that we'll do in human spaceflight missions. Then we also have representatives across all those implementing divisions that I showed you in the starting lineup of that first new HEO org chart. What we're doing is so important to the agency's success. We have observers from the Office of the Chief Scientist, Office of the Chief Technologist, OIIR, International Relations, and all of our technical authorities. And then we have people who are in the implementing program so that as we write down these requirements, we are making sure to sync between the capabilities that are developing and the needs that are developing. And those things are evolving and developing side by side. And we're responsible for stitching those together or braiding them together over time. Next chart. Once we have the requirements baselined, we have the goals, we have utilization capabilities defined at a top level, the strategic plans. Then we need to get those into level 0 utilization requirements. And then those need a handoff so that they go to the implementing division. And that is primarily for Artemis, the AES, as well as exploration systems development, which is essentially the transportation and the on-orbit and on-the-surface operations. And so we've been working a lot on how to get that phasing and scope knitted together in a way that will ensure that what users need is then planned for by the programs, and that the programs are ready to do that science when the time comes. Next chart. HEO 006, this is just a little bit of background about that document. It includes the utilization goals and objectives for all human spaceflight platforms, ISS, Commercial LEO, and Artemis. And it has sections that are owned by each mission directorate so that as decadal surveys are updated, as strategic priorities change, we can go back and correct those. And HEO always has a line of sight into what the other mission directorates want to do with its platforms. Then those don't change very often, so they're in the main body. And then we have a series of annexes that we can update and add to over time. The one that we've been working on the most intensely since January are what we call cornerstone utilization capabilities or use cases. These are some of the heavy hitters that we need to start planning for very early in Artemis in order to have the development time to have those capabilities ready. We'll also be working on a 10-year phasing plan that has those capabilities slotting in across the missions once we have a better line of sight into the architectures and into the funding for the development of the capabilities. We work on the integrated long-term LEO utilization objectives, because if you can test or do something in low Earth orbit, you should, and leave the lunar resources to Artemis, for example. And then finally, as we start defining the Artemis mission utilization objectives, we'll have specific annexes for specific mission timeframes. And so one of the big things we're doing in this Annex 4.1 is working on how the SDT recommendations translate into the top level requirements for that first crewed mission, and then and making sure that those are documented at the right level and they're ready to hand off to the programs over time. Next chart. And I wanted to give you a sense of what those early cornerstone capabilities are going to be. These early utilization capabilities, we really picked what we thought were the most important and some of the most complex things that needed to be defined early. So one is really framing all the different traverse approaches that enable the kinds of lunar surface science. Another is the end-to-end sampling strategy. How do we get a sample from when it's first taken at the surface all the way home, and how does it need to be collected? How does it need to be preserved and curated? What needs to be documented with it? And that includes not only lunar geology samples, but biological samples. We're also working on integrated planetary protection strategy, not because there are a lot of planetary protection constraints on Artemis missions, but so that we can use Artemis as a test bed and a preparatory place for future Mars missions. We're working on extended duration missions to address human research and BPS division research objectives. And those are interesting because those long missions with long stays at Gateway and longer surface mission activities, those are enablers of science that would otherwise not be possible in the Artemis architecture. And they also help reduce future risk of human missions to Mars. We're looking at integrated crew research, how we collect data on the crew across the Artemis architecture. Robotic utilization of HEO assets. This is very important because this is how you use things like the lunar terrain vehicle when the crew isn't there, and making sure that we put the right requirements on the HEO robotic assets so that we're optimizing the science return across the entire architecture. We're also looking at the integrated instrumentation strategy, both for external instruments as well as internal instruments that help us start framing what a laboratory on the surface would look like. And looking at PSR operations, the complex operations in those cold regions, both sampling, measurements, and ISRU in those very unique and very extreme environments. We're also talking about two things that are not exactly capabilities, but really important with long lead times. One is science team coordination, how a science team, once it's selected by SMD and has other members from other disciplines perhaps, how it would operate in the back room and coordinate with flight operations, because the level of EVA activity is something that's very different than our last 20 years of human spaceflight from a utilization perspective. And then also looking at interoperability, what interfaces need to be defined in a standard way, and how do we enable cost-effective development of utilization equipment, whether it's instruments or computers, so that the entire architecture works together. So as you can see, that's a pretty ambitious list. It's not everything that needs to be done, but they are definitely the things we needed to start with. Next chart. And just to emphasize that, you know, this, as we're working on these things, we are definitely working with our SMD college to use the richness of the Science Definition Team report that is directly feeding into this first Annex 4 for the first crewed landing. And this is just sort of a graphic reminding us all of that. Next chart. And that was all I wanted to present today. I fit right in my time, but I'll be around to answer additional questions when we get to that part of the presentations. Thanks.
Thank you, Julie. Look at that, right on time. Very good.